This is Wilfried, the PCB designer again. In a previous step, I verified the DDR4 interface with HyperLynx SI, and I saw that I do not have any issues. Now I want to check all other nets and interfaces. The recommendation in our PCB layout department is to use the integrated full board electrical integrity checker. Out of 63 design rules, the SI/PI expert Rory has defined the most applicable checks for us to run. These checks can go far beyond the limited scope of the built-in DRC in Xpedition. The main advantage for me is that I do not need to learn a new GUI and that issues can be fixed directly. For our design, we need to consider rules to check the board for EMC, PI and SI issues. Checking these things like metal islands and net crossing gap is possible either with manual reviews or using a 3D field solver. But it is very time consuming and especially for all manual tasks error prone as well. As mentioned before, this is just a very small variety of checks, and it is worth to mention that the rule library shipped with HyperLynx DRC also includes special checks for analog design like sensor net isolation and rules for IC packaging, and safety rules like 2D and 3D cribbage. We see that our design has issues with metal islands, vertical reference plane change, wire stubs and some more. We can easily identify checks with and without errors by the red and green color in the Analysis Control client. The Hazard Explorer of Xpedition layout is attended by a new tab called HLDRC. In this tab we can find all issues, and we are able to cross-probe from this dialog directly to the issue. This reduces hours of review meetings with the PCB designer and the SI expert sitting together and trying to transfer the simulation results from the time or frequency domain to the PCB design. Since this dialog is well known by all PCB designers, the adoption barrier is very low and typical functions for error handling and reporting can be used. Based on the metal island issue, I want to show how a typical issue review and fix could look like. With cross-probe enable, I select the first item in the list. The main screen instantaneously fit the screen on the position of the error. In this case, we need to add a wire on both ends of the plane. To avoid this plane could act as an antenna. The area where the wires should be placed is highlighted, and it is very easy for me to do this even without being an EMC expert. It is obvious that not all errors can be fixed at once. For this reason, it is possible to enable and disable checks individually. In our case, we just want to enable the metal island check. Reviewing the error count in the Hazard Explorer helps us to see if we fixed the issue. After fixing all issues, the design is ready to hand over to Rory, the SI/PI expert, to do the final electrical sign-off.